Hello and welcome to my workshop for this video on programming options for the F-14 Tomcat. And as you can see, I have a part-built F-14 here. This video is going to be generic ideas for programming for Tomcats. This model is a free wing version, but it's not specifically about how to program the free wing. So this will cover any Tomcat options. And my thanks to my friend Tommy for lending me his free wing Tomcat for use in this video. We could have just done everything on the servo monitor on the transmitter screen, but it's much nicer to see the various bits and pieces moving in action. It makes more sense to see it that way. So what shall we be looking at? Well, it's things like safety interlocks between the flaps and the fuselage, because if you try to sweep the wings with the flaps down, or try and put the flaps down when the wings are swept, then you're going to cause quite a bit of damage to servos or even to the flaps themselves. It's things like reducing or zeroing the aileron travel when the wings are swept, changing the travel of the elevators, or Tailerons if you like, when the wings are swept. And we'll also be looking at how to set up the gyro gain for wing forward and wing swept on different knobs on the transmitter, and even having a smooth transition between the two gyro gains when you sweep the wings. Now, we are going to do some things in programming this model that might seem unusual, but the reason is that when Jeti released transmitter firmware 5.06, they made an important change to the flight mode delay when you set things like rates to be flight mode separate. So rates, function curves, the elevator menu and aileron differential all lost the flight mode delay ability. They just jumped straight to the new value. And one of the things that I've learnt from people flying Tomcats is that when you do things like sweep the wings and you want the ailerons to go from full travel to zero travel, they don't want it to switch immediately, because for the time that the wing is still sweeping quite a long way back, you've lost your aileron, but the Tailerons don't have much effect until the wings are fully back. And similarly, when you switch forward, the ailerons would start working immediately, and that really can affect the handling of the plane. So I've worked out a different route to programming it, and it gets around that, and we have lovely smooth transitions between everything. But if you're wondering why I'm doing strange things like manually mixing aileron to the tail and creating separate functions for it, instead of just using the built-in elevator, and why I'm not using the obvious route of using flight mode delay to do a lot of the stuff, that's the reason why it doesn't work. Okay, I could just make this a very quick video and show you do this, do that, set that, and you're done. But you wouldn't necessarily learn anything. You'd be wondering why I've done what I've done. So, as usual, I'm going to take my time to explain what we're doing, why we're doing it, why we're not doing something else, so that you understand how your model is programmed. And that means that you can take what you've learned and you can adapt it to the model that you are programming, and to suit your programming style and the options that you want, rather than just follow slavishly what I've done. And you don't have to do any of this really on the free wing. For example, it has a power distribution board designed for a very simple radio, where it does all the Y leading and the mixing of the tails for you. But the one thing then you cannot do, of course, is reduce the ailerons to zero when the wings are swept, because then you'd lose the roll control from the tail as well. So it's much more fun to at least split out the 4 wing surfaces and the 2 tail surfaces to their own channels. We've got plenty of channels with Jeti, so there's just no point in trying to make it work with 6 channels, as sort of thing you could do with the power distribution board here. And the other thing is, I'm going to have a try, I hope it'll work, at doing chapters in the YouTube video. So if you bring up the timeline along the bottom of the video, it should be split into separate sections, each with a little title on them, so that it's much easier to come back to the video and find the particular bit you want, rather than have to trawl through the whole thing. So yep, it's going to look like a long video, but that's because we really put training into it so you understand what's happening. And I hope, yeah, we'll find out if I've managed to get YouTube chapters in it as well. So that's the intro done. Let's dive into the programming and see how we get on. Okay, here we are at the transmitter. We've given the model a name, we've selected our model type. Let's continue. I'm going to choose the standard 2-flap 2-aileron wing type, and the tail type, oops, I've got to come down to it. I'm not going to go for the elevator, and that's because, as I mentioned earlier, this problem with the flight modes separate in things like the elevator and the aileron differentials, it's not working. So we're going to get round it. So we want the normal 2H2V tail. And that's important because by choosing the 2 horizontals, the transmitter understands we've got 2 separate elevator servos, and if we do aileron mixing to them, they will go in the opposite directions. If we'd chosen a standard 1 horizontal tail, then in servo assignment we could have assigned another servo as a tail. But the Jeti would see 2 servos, but it wouldn't understand that they're left and right, and so when you try and mix aileron to them, that would not work. So that's why we've chosen the 2 horizontal, 2 vertical. As it happens, the F-14 has 2 verticals, so that's fine if you want to use the channels that way. But you might want to save channels and just use 1 rudder channel, happily send it through the power distribution box that's built into the model, which would separate it out as a Y lead in effect into the 2 rudder servos. And in order to save you channels, then in the next screen, the servo assignment screen, you simply assign the rudder 2 to something else. We'll come down from there. I'm not going to bother with all the rest of the stuff you would normally do in these gear servos and whatnot. That's not what we're going to be interested in programming this time. So we continue on. There's the standard stuff. The flaps will be done by flight mode, so we clear the control out. We're going to do the standard flap setting that way. Now I'm going to create a function for the wing sweep. I'll simply call it wing. It's okay to that. And that will be directly controlled by a 2-position switch. I'll choose this one. I'm not going to let the flight modes control it, although there will be a flight mode associated with it, which we'll see. So there we go, that's that done. And I also have to create a sort of aileron function for the tailplanes that we will mix into the tailplanes to give us the Tailerons, or elevators if you like. The reason I'm not mixing aileron into the tail is because when we use things like either the function curve or joule rates to stop the ailerons moving when the wings are swept, that would stop the tailplanes rotating as well as ailerons. So we want something totally separate. It'll be using the same stick. We'll get trims for it. So we'll say plus to that. I'm simply going to call it tail. Oops, for the moment. Okay to that. come across here, and I will use my aileron stick as its control. I could go on here and assign things like the gyro switches for this. I'm going to be programming an assist, so the main assist on-off switches and the programming gain knobs. But I'm going to do quite a specific section on the programming of the assist for this, so we'll come back and assign functions and controls in that segment. So we can move on, I think, to the servo assignment. We certainly don't need a tail assignment, because that's a function purely that will be mixed to our two elevator servos to give us the roll. I don't need rudder 1 and rudder 2 if I use the power distribution board that's in the model. I could just use rudder 1, so I could reassign that to something else if I need to. But if you're using a bigger model or central boxes, things like that, and you've got plenty of outputs available, then you might want to keep them. In this case, I wouldn't, because I've got a 12-channel receiver. You can see we've already used up 10 channels, and that's before we do things like gear and steering, whatnot. So what I'm going to do now is something I do in most of my training videos, and you do not have to do it at all, and that is to change the sequence of the servo assignments. And the reason being simply to make it easier to watch similar items moving when we look at the servo monitor later on. So if I'll put aileron 1 there and aileron 2 there, just to stop it looking annoying, I'll pop that as rudder 1. Then I'll have flap 1, flap 2, I'll have elevator 1 and elevator 2. I can put my wing there and clear out that one for the moment. Okay, remember, don't bother doing this unless you really want to. This is done just for presentation purposes, so it's easier to watch similar things moving later on in the servo monitor. On we go, create and activate model, yes. Say OK to that, so we won't pair the receivers now. No, I don't need to. Good, that's that done for now. Okay, so we've done the very basics. We've checked that the servos are operating in the correct directions for the ailerons and the elevator and anything else you want. The flaps have gone to the mid position because, of course, there's no control assigned, so they've gone to the 0% travel position. And I have not plugged in the wing sweep, because the last thing we need to do is that suddenly go chuntering along whilst the flaps are down here. So we can either program the flaps so we can get them up, or unplug them, manually lift the flaps into position, and then check the wing sweep. Just aside, on the free wing model, you could get by with using the 2 aileron 1 flap type of wing, because the power distribution board will lead the flaps out for you. It just means you lose the ability to match their travels precisely if the servos aren't moving very, very accurately together, which they may well not do, since they tend to be cheaper servos fitted here, but I'm sure plenty of people are using it quite happily. But for the moment, what I'm going to do is go ahead and do the basic flap programming, and it will be done by flight modes. So first of all, we need to create our flight modes, and I'm going to create another one whilst I'm at it. And so they're going to be my default flight mode, my takeoff and landing flap flight modes, and the wing sweep flight mode, and it will be placed at the top so that it takes priority over the other 2 switchable flight modes, which are the flap ones. We could put it down towards the second bottom on the list and have the flap modes above it. it doesn't make a huge amount of difference. I think all it does is switch around the way that you build in the protections for the flaps and fuselage not hitting one another. I've chosen, in this case, I will put the flight mode wing swept up at the top, and therefore the types of protections and logic switches we'll build in later will be suited to that. So by the magic of pausing the video, ta-da! Magically, we've named all the flight modes, put in the delays, and set the switches. Now, I've put in a delay of 3.5 seconds to sweep the wing, and then a delay of 3.5 seconds as it comes back forward. And the reason for that is I've measured how long it takes the wing basically to move, and it's about 3.5 seconds. So that will allow anything that we do need to move with flight mode delays to go at that speed. And that will be things like the trims. One thing that it does affect, of course, is that switching from the takeoff flight mode, which is the flap setting, back to default is going to be very slow because it's going to take 3.5 seconds. Whereas flaps down is, I've set it for 1 second there. You're just going to have to live with that, I'm afraid. Can't get everything. We can't set a separate delay coming into default depending on whether we've come from swept wing or takeoff flight modes. And so while I think about it, we'll come out of there. We go to the function curves menu, because there's an important column here, the flight mode delay, whether flight mode delay applies to that function or not. And we're going to come down and say it does not apply to the wing sweeping mechanism. Why is that? When we've programmed in a flight mode delay. Well, we don't want the sweeping of the wing to be delayed after we've moved the switch. The way it works in these free wings is basically it's driven by retract servos, which simply move from one end to the other whenever the signal passes the midpoint. And so when we move our wing sweeping switch, which will be this one, we want that mechanism to start off straight away. If we've allowed a flight mode delay, it would basically take half the time of the delay before the signal would cross the midpoint and off the wings would go. And we don't want that. So we've taken that out so that we get an instant response by the wing sweep mechanism when we move the switch. Okay, let's go and do our what am I talking about? The flap. So we'll come down here, control, as usual. This is all very standard stuff for the flaps. Now we can come to flight mode separate, ailerons flaps adjustment, flaps, and we'll dial it up. And so there's my flap switch, there's the modes going. It's all at 0 at the moment, so default is normal fly around, flaps up. Let's swing the control and see which way they go. No, needs to go that way. Oh, the flaps are moving in opposite directions, so we'll have to reverse one of them. I'll just pop it back to there for the moment, and I'll go and reverse one of the flaps, and we'll be back in a second. Right, that's done. I've reversed one of the flaps. You could do it here by knocking out symmetry and adjusting them both in opposite direction values, 1 plus 1 minus, but this is going to make life just so much easier if they're both going the same way to the same thing. So that way is bringing the flaps up. What sort of values we're looking at? And the flaps look level at about there. What happens if we go to 100? We can probably live with that. And if this was my model, really, I would slightly fine-tune the flaps. I'd be measuring them each independently, switching off symmetry and getting exact values. But it will do for the purposes here. Takeoff setting. That's a bit too much down flap. So we'll go to about there again. You would read the manual, see what your settings are. And landing. Go for something like that. Ignore the actual values put in here. For your model, you will put in the values relevant for it. These are just demonstration things going on, so I'm using values that just help demonstrate stuff. Okay, so we've now got working flaps, which means we want flight mode separate trim on the flaps. So we come out of here, digital trim, elevator, separate. And that way now, when we put the flaps up and down, we can have the elevator trim working for each separate of the 3 flight modes, and it will move at the same sort of rate as the flaps do. But while we're here, normally I don't bother making the aileron trims flight modes separate, but for this plane I will. Just gives us a little bit more options with what might be happening once we sweep the wings. Okay to that. And oh yes, importantly, there's one more thing in digital trim. We are going to add in a trim to that tail function that we created, which is what we'll be mixing into the elevators to give us the Tailerons. Now it's very important you do this, because when the wings are swept, we've disabled the ailerons, and you may need trimming in that mode. So we need those Tailerons to respond to the trim button. So we go in here, we select that. I'm not going to move a control because I want the digital trim that we normally use for aileron. For me, that'll be that one. Say OK to that. And I'm going to have it move the tail function. And let's just have a look along here. It's global. Yeah, I'm happy for it basically to be global. In other words, the Tailerons will also trim all the time along with the ailerons, but they will also work when the ailerons are disabled. If you desperately want to, you could switch that to flight mode separate and remove the Taileron trimmability whilst the wings are forward. That's up to you. So we'll say OK in there. And it's time to move on to the next bit, which is we shall plug in now the wing and see what happens. The flaps are up, so it's quite safe for the wing to fold back if it has to. Right, the model now appears to come alive. The lights come on because the wing fold mechanism is done through the power distribution board. There's only one connection to the receiver. It goes through to the power distribution board, which sets it out to those 2 retract servos. Let's see what happens. Move the switch. It's initialized. Oh, and the flaps have gone down. So let's bring that. We don't like the look of that at all. Let's find out what's going on. And of course, the obvious thing is I didn't set a flap travel with wings swept flight mode. Silly me. I forgot about that. So come back here, ailerons flaps adjustment. I will disable the wing sweep by removing the servo, and we have to go to, there we are, the flaps swept setting, which will be the same as in the default flight mode. I'm annoyed at forgetting to do that, but there we are. You see, even I make mistakes sometimes. So, wings swept mode, flaps are up. Oh, wrong switch. Back to default mode, flaps are up. And now the flaps work. And the reason, one of the reasons we put the swept mode at the top of the flight modes was if we go to wing swept mode, and I now operate the flap switch, The flap flight modes will have a little tick against them, but because the swept mode was higher up in the list, it's overridden them. So that alone has prevented us from putting the flaps down when the wings are swept. Right, let's put that there, and we'll try plugging in the wing sweep again. And there we are. Let's have a look at what happens. Right, flaps are up, wing sweep go. Nice stuff. And forward. Okay, there we are. It's not going the way I would like with that switch, so I'm just going to jump into the servo setup menu and reverse the output for that, so that with my switch back the wings are back, and with the switch forward the wings are forward. Let's see, okay there. There we are. Switch forward. Okay, so the basis of the wing sweep and the flaps is working. We've still got to build in a lot more interlocks into it to protect it. And then we'll get on to the tail once we've done all that. So our next step is going to be building the safety interlocks between the flap and the wing sweep. Right, it's time to have your espresso and chocolate biscuit, because you need the caffeine and sugar for the brain work coming up. We have to set quite a few logic switches cascading off each other to protect the flaps from hitting the fuselage when the wings are swept. Now, at first you might think, well, that's very easy. Simple logic switch that the sweep and flaps up is the only way that this wing sweep can work. But we have to account for human behavior. For example, what if you take off with the flaps in the takeoff position and you forget to raise them, or you've done a slow flyby with the flaps down and you forget to raise them, and subsequently you go to switch to sweep the wings back? Well, the logic switch will say flaps are not up, so we won't sweep the wings back. Fine. And suddenly you remember why the wings aren't sweeping, and you raise the flaps. What would happen is immediately the logic switch would say, yep, that's okay, we can go to swept wing mode, the wings start sweeping, everything starts happening. But the flaps start rising slowly when you raise the switch. Remember, coming into default or mode or swept wing mode is going to take some time. And the flaps are still partly down when the wing sweep hits the fuselage and starts binding. So we're going to have to take account of the fact that if you're in this state where the flaps are down and you sweep the wing, and we're going to put an audio warning in here as well to remind you, what you really ought to do is push the switch forward again, raise the flaps, give them time to come up, and then sweep the wing. But people won't. They will just think, wings back, oh, it's not working, audio warning, yep, raise the flaps, and they'll do that. So we need to protect against that happening. So here's how we're going to go about it all. Let's go first of all into model, the function assignment, the wing sweep, and we'll remove the switch as the control. So we'll clear it out. Oh, by the way, have your model switched off during all of this, because you want to be absolutely sure on servo monitor that you've got it all working right before you plug it in and find you've got some mistake and the flaps are binding against the fuselage. And obviously you don't want the wings sweeping back and forwards and flaps doing things as we're setting all the switches, because they're just going to cause crashing conflicts there. So model off, it's all on the transmitter screen for the moment. And And we come down to advanced properties, the logical switches, logic switch 1. I won't bother labeling it, I'll just enable it. Come down, and control 1 is going to be the flap switch in the up position with a delay. So I'll put the flaps to the mid position, open that, go to the up position so that at flaps takeoff and landing it's off. So flaps up, switches on, say OK. There is no control 2, therefore there's no condition to it, but what we want to do is build in a delay. Now these little symbols mean ramp, so it happens over a period of time, or if you press on it with the programming dial, see how it toggled to a vertical sign. That means it's just an on-off, so it will delay a length of time and then simply switch. And we're going to set it to the length of time that it takes the wings on your model to sweep, which is the length of time we've already put in the flight mode delay, if you remember. And for this model, it's 3.5 seconds. You set it to the time for your model. So if we switch it off, the flaps are down. When we switch it back on to the flaps up, you'll see this goes on immediately because the physical switch has come to the on position, but the output will take 3.5 seconds to come on. So here we go, switch is moved, 3.5 seconds later that comes on. Now you're wondering why we're doing this, you're about to find out. Come to logic switch 2. Again, you could label it if you want, I won't, I'll just enable it. Come down, control 1 is going to be, I'll put my switches back to there, the wing sweep. So wing sweep, say OK, and control 2 is going to be logic switch 1 that we've just made. Okay, and the condition is and. Now this is what protects the wing if you've done that scenario where the flaps are down, you've tried to sweep the wing back, you've realized it's not sweeping back because the flaps are down, and you raise the flap switch. So this is saying that for the output to go on, we must have the wing sweep and logic switch 1, which was your flap switch, in the up position. Then the output can go on. If either of those are not correct, the output will be off. Okay, but here's the scenario where you sweep the wings and then raise the flaps. This will take 3.5 seconds to come on. So you're flying around, flaps are down, you sweep the wing with the switch, but the output won't go on until you've raised the flaps and 3.5 seconds have gone by. So the flaps can get up before the output of this goes on. So we'll now raise the flaps. 1, 2, 3.5, bing. There we go. We're getting there, folks. Next, logic switch 3. Now control 1 is going to be the wing sweep switch in the forward position. So move it forward, okay, to that. And then control 2 is going to be the flaps in the flaps up position. So I put my flaps to the middle, move it to the up position, say okay to that. And the condition here is once again an and. If you're wondering what this is about, you'll soon find out. Say OK to that. And finally, for this round anyway, logic switch 4, it's going to be an A on, B off switch. So come here and you'll see what we're up to. The A on, B off. And A, control 1, is going to be logic switch 2. To that, and B, which will switch this output off, is going to be logic switch 3. And logic switch E, remember, was flaps up, wing forward. And so the result of this is we start in the off condition. To switch the output of this on, condition A needs to switch on. Condition A was logic switch 2, which is the wing sweep and the flaps up. So the flaps are up, wing sweep on, output goes on. Now the output of this will only go off when logic switch 3 becomes true. So I can move the flaps around all I want. And you can see logic switch 2 goes off, and it'll come back on after the 3.5 seconds. It doesn't affect the output here. We need logic switch 3 to become true, and logic switch 3 becomes true when the flaps are up and the wing is swept forward. So if the flaps are down and I sweep the wing forward, nothing's happening. When I bring the flaps up, there, that became true, and that switches it off. So at last, we now have a logic switch which we can use to control things. And what it's going to do is control the swept wing mode, flight mode. So we'll start by saying OK to that. Go to our flight modes. And the swept wing mode will now be controlled by logic switch 4. Clear that out. In we go, logic switch 4. OK to that. So we've got flaps are up, wing is forward. How do we get into the swept wing mode? Well, if we just move the switch, it'll go straight to swept wing mode because it's quite happy with that. If the wings are swept and we try putting the flaps down, those modes come on, but because they are lower priority than swept wing mode, which is at the top of the list, they can't affect it. So we can move the flaps and we stay in swept wing mode. Move the wings forward, we come out of swept wing mode into whatever those are. But what if we've gone into swept wing mode? We've accidentally put the flaps down, haven't realized it because you've knocked the switch, and you want to bring the wings forward. Now it won't come out of swept wing mode. Do you remember that last A on B off switch we made? The B condition to switch this off required the flaps up and the wing swept forward, and it won't do that until we do that. So we've protected there. We can't bring the wings forward and the flaps down at the same time. And finally, what other condition have we got? Yes, flaps are down, wing is forward. We try to go into wing sweep and it won't happen. So we think, oh, raise the flaps, and it takes 3.5 seconds for that to come on and change to swept wing mode. Okay, well, now we're getting there. Next thing we need to do is come to the function curves. And do you remember we removed a control from the function assignment for the wing? So there's nothing actually moving the wing at the moment. And we go into its curve, and we'll change it to a constant type. We'll come down, move it to -100%. Say OK to that. And now I'm going to change it to flight mode separate. I'll come back, and because we've moved it to a constant curve at -100% before we changed it to flight mode separate, then all flight modes will be showing this value, which means I only need to change one of them, which was the swept wing mode. So I change to swept wing mode, and I come down and I change that to +100. Okay, so for each of the flight modes we've set a wing function curve. In swept mode it's at +100, default mode, -100. Each of those modes is fine. Okay. And also notice we do not want a flight mode delay on the wing sweep. So you'd come across here and toggle that from a tick to an X. Right. That, I think, completes the actual programming of that. Now we'll come to the warnings in a moment. Let's have a look. What I've done here is on servo 1, I've assigned that also as wing sweep and put in a 3.5 second delay purely for the sake of demonstrating here. You don't need to do this, of course. So this is the wing sweep. Goes like that, because that's basically running off the function curve now. And this one is actually going to show you, because it's going slowly, how the wing is moving. See, like that? And it just gives us a representation of it. 5 and 6 are the flaps. Yep. So we start with the flaps up. The default mode, we can put the flaps to takeoff, flaps to landing, and now with the flaps down in any position we try and sweep the wing, nothing happens. Flaps to takeoff, the wing stays where it was. And only there does it go swept. So wing forward, flaps happily work. Wing swept, the flaps don't work. If I've left the flaps down and I sweep the wing forward, it won't come forward, it won't conflict with the flaps. And if I've done that business of taking off with flap, I go to sweep the wing does not sweep, and I think, oh drat, raise the flaps. There's that delay while the flap comes up, and then the wing will sweep. Okay, now what we'd like to do is build in an audio warning to you that you have tried to sweep the wing while the flaps are down. Or operate the flaps while the wing is swept, so that you realize why things are not working. So we'll come out of there, out of that, back to advanced properties, logic switch, go to logic switch 5. It's wise to give things a name, so when you come back to them in the future you can think, what on earth is that logic switch there for? What does it do? But I'll not bother for the moment. Yeah, well, I'll tell you audio, just to show you what we can do. Okay, and control 1 will be the wing sweep in the swept position. So we put it in the forward position, move it to swept. Control 2 is going to be the flaps, and we want it to be when flaps are down. And it's a 3-position switch, so we put it to the middle, press that and move the flaps up. Say reverse, and so the flaps down, it switches on, flaps are up, it switches off. Okay, to that the condition is and. Okay, there, and we can now use that in a sounds on event. So it's going to be logic switch audio. The file, I've made a custom file using the rc-thoughts.com website, which says warning, blah, 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 so we'll find our way down to that. Yeah, warning, flap switches down. I'll turn the volume up again.
Warning, flap switches down, wing sweep inactive.
There we go. And I'm going to set that to repeat as long as the switches are in the wrong position. There's a conflict, so it doesn't just warn me once and I miss it because there's a lot of noise going on in the background. And it'll switch off once we get the switches to the correct condition. So let's have a little look at the servo monitor. So wings forward, flaps are up. Happily operate the flaps. Flaps are up. We can operate the wing sweep. But should we have left the flap down and try and sweep the wing?
Warning, flap switches down, wing sweep inactive. Warning, flap switches down, wing sweep inactive.
And this is where you go, oh yeah, the flaps are down. Raise the flaps. The system gives time for the flaps to come up before it sweeps the wing. And she stopped talking because you're no longer causing the alarm. And should the wings be swept and you accidentally knock the flap switch?
Warning, flap switches down, wing sweep inactive. Warning, flap switches down, wing sweep inactive.
There we go. And I think that completes everything for programming the wings. So what we'll do now is switch to the other camera and watch it all in action. Here we are then with the model up and running after we've thoroughly tested it in the servo monitor on the transmitter screen to make sure it's not actually going to go wrong on the model, because you don't want to do any damage. So the wings are in the forward condition, the flaps are up. I'll prove that the flaps work. There's takeoff, there's landing, and we'll prove that when the flaps are up we can sweep the wings. Now with the wings swept, I shall try to put the flaps down accidentally.
Warning, flap switches down, wing sweep inactive. Warning, flap switches down,
and if
wing sweep inactive.
In a hurry try
Warning,
to sweep the wings
flap switches
forward,
down, wing sweep inactive.
They won't come forward. If I was to raise the flaps now with the wing sweep in the forward position on the switch, the flaps still won't come down. They're in the down position. If I raise the flap switch with the wing switch in the forward position, now it'll come forward. Okay, we've done that bit where we've taken off or done a slow flyby and we've forgotten to raise the flaps, and now we try to sweep the wing.
Warning, flap switches down, wing sweep inactive.
So you panic.
Warning,
and raise the flaps.
Switches down, wing sweep inactive.
So it will now raise the flaps and pause when crut happen and then sweep the wings. So that's lovely. We've got a very good set of protections built in there. Now we come to programming the ailerons. What we want them to do is work when the wings are forward and not work, stay at neutral, when the wings are back. And we would like this to gently transition over the sweep of the wing. So instead of just suddenly switching from 100% travel to 0% travel, or from 0 back to 100 at the moment you flick the switch, it would gently change the travel value on the way back. Also, for some people, they would like it a little bit more scale and have the ailerons only come upwards, not go downwards, because I believe the full size didn't use ailerons so much as spoilers on, and perhaps you'd like it to do that. I know some people do work it that way on this model. And also some people would like, again like the full size, to have full span flaps, so the ailerons would be flaperons. So we're going to look at all of that. The first thing we need to do is consider how we are going to reduce the travel of the ailerons to 0 when the wings are swept. And this is where we hit that real problem I mentioned right at the start about not being able to use flight mode separates in the function curves or rates or differential or what have you. Unfortunately, what we do have to do is use the dual rates, because if you try and use things like the function curve to take it to 0, you are going to get some very nasty effects. So please don't even try it. If you test it out, you'll find you get servos barely responding, doing their own thing. Just please don't go there. So we do have to use the dual rate for it, which means that you haven't got the dual rate available for other things in this. Does that matter? I mean, to be honest, most of the flying of jets that I do, I don't bother using rates. I just set it up nicely. But that's what we're going to have to do this time. So to start with, we need to make a logic switch. And that's what's actually going to give us the timing of the transition, rather than using the flight mode delay. Sounds odd, but we're just forced into it because of the version 5.06 software. So we'll go to logic switch 6. I'll give it a little label. Call it that. Come down. And control 1 is going to be logic switch. Golly, which one was it? This is where I wish I had named them all. It was logic switch 4, the A on B off switch that's used to switch the flight modes. Press prop. So we want that view of it, but we want the center to be off. So instead of going from -100 to +100, it will only go from 0 to 100. There we go. So it will go from 0 to 100. And we want it to be 100% when the wing is forward. As you can see, my wing switches are in the forward position, but it's at 0%. So we're going to press rev to reverse it. And now with the wing forward, it's at 100%. With the wing swept, it's at 0%. Say OK to that. Now we're going to change it over here to linear. There we go. So that instead of just going 0%, 100%, it can have all the values in between. We come down here, and this is very important now, there's no condition, we come along to the ramp timing. And so now, if I was to switch it, it'll just go from 0 to 100% instantly. But what we can do is put in the ramp time. And the ramp time is going to be twice the time it takes for the wing sweep to happen. So we've said that on this model, the wing sweep's taking 3.5 seconds. So that's what things like the flight mode delays are set to. In here, we're going to set it to twice that. And the reason is that the ramp time is how long it would take to go from +100 to -100, or -100 to +100. But remember, we took the center out in here. It's only going halfway from 100 to 0. And so we need to double the time, so that if it takes 7 seconds in this case to go from +100 to -100, it'll take the requisite 3.5 seconds in here to go to 0. So I'll open that field, press the menu button to change it to 1 second at a time. Off we go. And now, if I operate the switch, this will count down from 100 to 0 in 3.5 seconds. So, start, 1, 2, 3.5. There you go. And the same going upwards. Start, 1, 2, 3.5. There we are. Lovely. What we can do now is use that as the control in the aileron dual rate. So you come down here, dual rate, ailerons, and set the switch. Here's our logic switch there. Okay to that. We need to switch on proportional. Now it looks like that. And if we sweep the wings, we can come back up to the rate we want when the wings are swept, which would be 0. Bring the switch forward, it should go back to 100, and there we are. We can see the rate smoothly moving over the 3.5 seconds. Start. 1, 2, 3.5. Okay. Let's look at the effect on the ailerons themselves. I'll bring them to the swept forward bit. And let's check our output. I think it's 3 and 4 are the ailerons. So I can move full stick. I'll hold the stick over and sweep the wing. Look at it smoothly moving down there. And you see it matches the time it takes for the wing sweep. I'll keep the stick held over at full aileron, and then watch the time for the wing sweep and the ailerons coming back up to full travel. There we are. Now the important thing is that it continues to work smoothly without any nasty effects if you're moving the stick whilst the change is taking effect. So we'll start moving the stick and we'll change that. And it goes to 0 and again on the way up. Okay. Now, I mentioned before, please do not try this with things like the function curves or the others, because if you were to watch what happens when you move the stick in here, it can do some really nasty things. I mean, you would have control problems. So that's why we have to use the dual rate. Okay, say okay to that. Now, one of the other things you can do, we mentioned, is have them just as spoilers, so they'll go up rather than up and down. For that, we'll come to aileron differential. We can have it in all modes. Come to the down aileron, click that, press the menu button twice so the step is 100%, and that's it done. Let's have a look at this. So 3 and 4 are our ailerons. I'll go left aileron. That moves up, but the right aileron doesn't. I'll go right. Right aileron moves up, the left one doesn't. There we are, like that, and sweep the wings. And there we go. Sweep them forward again, and our rate's coming back. And if you'd like to use them as full span flaps, okay to that, come down to your butterfly flaps and into here and set some value. You'd have to have the model switched on and do that. And even that will work, even though we've said they will only go up as ailerons. Because we used the differential menu, they'll quite happily go down. You could have used the servo setup to have 0% travel in the down direction, and then your ailerons, or if you were using, say, spoilers, genuine spoilers, would only go up. But if you'd done that, then your ailerons could not go down with the butterfly or any other menu. One final thing we need to consider is what is going to happen about the aileron trimming. We need to be able to trim the roll when the wings are forward and the wings are swept, but we've disabled the ailerons from acting when the wings are swept. And we want the trim to be working on the Tailerons, which is what we have already set up earlier when we created a tail function and allowed it to trim using the same button as the ailerons. But if we do need to do any aileron trimming or roll trimming whilst the wings are swept, we don't want the ailerons to be moving. We want the ailerons to be the same. We want them to be at 0 and stay at 0 whilst the wings are swept, so that we're not getting a differential downwash affecting the angle of attack on the Tailerons differently on each side. So we're going to do that through the fine-tuning menu, digital trim. Remember, we've probably already set ailerons as separate. You may or may not prefer to have them as separate in flight modes for just trimming in case you get slight roll due to flap, but you're definitely going to have to set them separate now, because we're going to come along here and set the rate for each flight mode individually. So at the moment, in each flight mode, it's step 2%, rate 100% in either direction. What we're going to do is switch to the swept wing mode, go in here, and take it down to 0 in both directions. Now we'll switch through all our modes and make sure that the trim is working. So swept will have 0 travel, so the trims will not have any effect in swept wing mode. Back to default mode, the rate's 100%. Takeoff mode, rate 100%. Landing mode, 100%. Check again. Swept wing mode, 0%. Okay. Let's have a look at the effect on the servo. 3 and 4 are our aileron servos. Default mode, let's go to 10%. In default, we'll go to 20% in takeoff mode. This is just to demonstrate it. And we'll go to 30% in landing mode. So there we are. There's our trims moving through the modes. And when we go to swept wing mode, it should go back to 0. It does. And I'll press the trim buttons. Nothing happening. It won't work there. I'll hold on full left trim till it's run out, and it won't change the aileron servos. And then they'll happily go back to the preset trims in those flight modes. Okay, and that concludes all the programming for the ailerons. Okay, so let's switch it on. Let's have a look at everything working, and we can also then, seeing the model, set up values in the aileron flaps adjustment here in the butterfly menu. So we're going to transfer over to the other camera now so we can see this actually in action. Here we are then, checking the ailerons, and they've been set as spoiler on mode, so they'll come up only. So there we are. That's left stick, right stick. So the aileron on the other side is going up, but it won't go down. And this one comes up, but won't go down. And if I hold on full aileron and we go for the wing sweep, you'll see the aileron smoothly go down to 0. And the same as we come forward, it'll start smoothly coming up. There we are. And we'll move the aileron during the transit to prove that it's working nicely and not doing anything silly. There we are. And the reason we used the logic switch as the input to this logic switch rather than just the wing sweep switch is so that we don't have the ailerons working or not working when the wing is not swept or unswept. And it follows that. So I'll accidentally put the flaps down.
Warning, flap switch is down, wing sweep inactive.
And I'll try and move the wings
Warning,
forward.
flap switch is down, wing
They
sweep
won't.
inactive.
So I've moved the sweep switch forward and the ailerons still don't work. It won't happen until we get there. And similarly, if the flaps are down, the ailerons are working, and we move the switch to sweep the wing, we'll get the warning that it won't sweep, and the flaps will still work.
Warning, flap switch is down, wing sweep inactive.
There we are. And finally, if you want the full span flapper on, then the aileron section in the butterfly menu, do that. We can get there and go for full span as well. Some similar value. It's up to you what values you want to choose. We've still got our working there. And so there we have all the working ailerons. Now we come to programming the Tailerons, and I think the first thing I'm going to do is make the roll trim on the Taileron only work when the wings are swept. I've just a gut feeling that if we allow the Tailerons to trim in all flight modes, but the ailerons only to trim with the wings swept forward, we could start to get a bit of accumulation of tail trim running up. So I'm going to come down here to the tail. I'm going to change it to separate. Come across here to the rate, and we want it to be 100% rate when we are in wing swept mode, but nil in the other modes. So we're in default mode. We'll take that down to 100. You might think differently. You might prefer to leave it trimming in all modes. Come across here, highlight it, double press of that. We can take it to 0, and without coming out of it, move the mode 0, 0. Okay, so let's check it. In default mode, flaps 1 and flaps 2, it's 0. In swept mode, it's 100%. The reason for the delay there was, remember, the system's waiting for the flaps to come up. Normally it will run immediately, and so it will stay there because we're doing it per mode, nice and safely. Good. Now we can go to mixing it in from tail to the elevator at 100%. We will have to say that it's not single direction, so it's not working like you would do elevator to flap mix, which is the sort of thing you'd have here. You want elevator to aileron mix. So we just press the programming button there to make it single direction. And the other thing we want is to switch the trim on. And now let's have a look. Before firing up to the model, I would turn the mix outputs down to a very low value. As you can see, you get a mix output for each servo in each direction, so that you can get the travels really well matched. This is just for the roll response, the aileron response. This is not for their elevator travel, so that would be a separate thing. And I would recommend, as I say, turn it down to a very low value to start with, and then put your measuring equipment on your Tailerons and start turning the travel values up. That way you don't risk overdriving a servo. Remember, you're probably looking for something around about 50%, with the elevator response at about 50%, so that when you start pulling the stick towards the corner, both elevator and aileron, you've got the travel there to do it. Let's have a look at the effect. 7 and 8 are our elevators, so if we pull up, the bar goes to the right. So if I push left aileron, the left aileron should come up, which is to the right, and the right taileron, not aileron, sorry, taileron, would go down. So with elevator they both go the same way, with aileron they go the opposite way, and they are going the correct values as well. Lovely. Let's consider what would happen if, or what you would do if you do want the Taileron roll to switch off when the wings are forward. The free wing one here, their instructions say just leave the Tailerons working all the time. But I think some other people with different models prefer the Tailerons to come off. Well, here we want a reverse version of what we did for the ailerons with that logic switch, but we cannot use the aileron one because it was set up to switch them off when the wings are back. And we want the Tailerons to switch off when the wings are forward. And you can't just reverse the input of the switch. In this case, you can't use the same switch and reverse it, because instead of going from 100 to 0, it would go from 0 to -100. Let's go and have a look at doing that, just so you're really sure of what you're doing. Logic switch. So it's going to be a copy of this one, except that if we have a look in here, remember we pressed rev, so we're going to do it the other way around. We just won't press rev. So if we have a look, it was logic switch 4 linear with 7 seconds. So here we go. We'll label it tail. Enable it. Come down, select logic switch 4, but this time we're not reversing it. You can see it's proportional, that's what it looks like. We take out the center, and let's prove that it's going the right way. So this time, with the wings forward, it's at 0%, and with the wings back, it's at 100%. That's good, that's what we want. Take it to be linear, and we come down, no condition, and set the ramp to 7 seconds. Or twice whatever your wing sweep time is. And now, if we change from default to swept mode, we'll watch the mix value switch that we'll be using go from 0 to 100. In the 3.5 seconds, test it, start, 1, 2, 3.5. There we go. Lovely. So now we can go back to the, what was it, the mixer. Edit that and use that switch. Because the switch needs to be proportional. Say OK. Have a look in here. Let's do that, and let's sweep the wings, and there we go. Its aileron response is coming up. Put the wings forward, its aileron response is going down. And let's just show we've got full elevator still. And sweep the wings, we've still got full elevator. Now the wings are swept, they should respond to aileron. And we'll sweep the wings forward, and the aileron response is reducing to 0. Sweep the wings back, the aileron response starts increasing until it reaches the full value. There we go. Okay, I will remove that. No, we'll leave it in for demonstration purposes. We'll say OK, and OK to that. OK. Now let's prove that the trimming works on the Tailerons. So we'll start trimming. We're in default mode. So remember, we made it flight mode separate. So the trimming is not working on the ailerons, it's working on the wing. Now let's switch to wing swept mode. The aileron trim comes off the ailerons themselves. But the trim, there we go, it's now working on the Tailerons. So there's a bit of left trim to the Tailerons. It's coming off while the trim comes on to the ailerons. Okay, and let's just test everything. We'll take that trim out for the moment from the ailerons. I'll switch there and take the Taileron trim off, because we'll just prove later. There is a difference, incidentally. I'll turn the volume up a bit so you can hear this. For the ailerons, the 4 main controls, as you know, if you hold the trim button down, when it gets to 0, it will stop. So we'll do that. There. But with the additional trims that we created, they don't stop. So we'll move it. See, it makes a different noise. It doesn't make the rising and falling tone. But we'll now just hold the button down. See, it goes. You don't get to know you've got a center. So be very careful about holding the button down. Okay. And I think we can now go to the tail planes. So we'll switch to the other camera and have a look at everything working. Right, we're back with the model to demonstrate the roll control through the ailerons and the Tailerons. And we have it set up as we've just seen on the transmitter, where the Taileron roll control switches off when the wings are swept, which, I remind you, you don't do with this particular free-wing model. You have them running all the time. Let's have a little look. We've still got the ailerons using just sort of spoiler control, so they're working. Just responding there. And the Tailerons, as you can see, the elevator's twitching them, but they're not responding to roll. Now I will hold on full left aileron and we'll switch to swept wing mode. So watch the aileron go down, but the Taileron take its place. There we go. We've got two Tailerons. Again, I'll hold Taileron in and sweep the wing forward. So watch the Taileron reduce back to neutral and the aileron come up in its place. So there we go. They're working okay. Now let's prove the trims. So with the wing swept forward, the trim button should only trim the aileron and not the Taileron. Yep, it's working. And with the wings swept, we can now trim the tail plane independently. You can see the ailerons have gone back to neutral. So now the tail planes are trimming, and when we switch forward, the trim will smoothly move from the Taileron to the aileron. And there we are. Case proved. And we're on to the final stretch now, programming the gyro. Specifically, this is going to be programming the assist, but much of what I do can be replicated with external gyros like a Cortex Pro or an iGyro. You're just going to have to adapt some of the things a little bit. For example, the gain values on an assist will go from -100 to +100, whereas with other brands of gyro generally it's from 0 to +100 or 0 to -100, which would give you the two different banks. Now in a Jeti assist you've got 3 of them, but they're called assist modes and they're switched separately rather than using the actual gain value. So what I'm showing you here can all be adapted to suit those others as well. Now, let's first of all look at the functions I've created for it. We've got quite a few new ones here. Well, we've got the assist mode, so that's going to be switching the assist mode. And the reason we want to be able to switch modes is that within the different modes, we can switch stabilization on and off per individual functions. So we'll be able to switch off aileron stabilization when the wings are back, and we'll be able to, if you wanted to, switch off the Taileron roll stabilization when the wings are forward. You wouldn't with necessarily with the free wing one because the Tailerons are on, but I'll show you how to do it all in case the model you're programming wants the Tailerons off when the wings are forward. We've got the gain function, but you can see assist mode and gain do not have a control assigned to them at the moment. Now what I've got going on this model is we're going to separately be able to set up the gain when the wings are forward, and then when we sweep the wings we'll set the gain by a different knob. So P8 we'll use to tune the gain when the wing is forward, and P7 when the wing is swept. The reason for doing that is that it allows us to keep the gain at the different modes. But very importantly, once we've landed, we can look at the output on the mode gain channel. We can read the value with the wing forward, read the value with the wing back, permanently set them into the function curve, and have a nice smooth transition between them as the wing sweeps. And I've got my gyro master as always, I use that switch there. So we need that one to be able to switch the assist on and off for its stabilization. We don't use the mode switch because you see one of the 3 modes can be off. I never use that. I always use the separate on-off switch. Okay, we'll move on from there. Servos, we need a channel for the mode, and we need a channel for the gain, and we'd have one as well for the master. We don't need one for the gain forward and gain swept. They'll be just working the output on the gain channel. Okay, there. Now then, we can move to working out what is actually going to control the assist mode. We don't want it simply to be the forward and backward or swept wing switch. And the reason being, as we've seen through all the logic switches we've put in, you could end up pulling the switch back when the flaps are down. The wings don't go back. What would happen is everything would jump to the gain and stabilization on the tail planes. And similarly, if you'd moved the switch forward when after accidentally moving the flap switch down, the wings wouldn't come forward, but everything on your stabilization would jump to the wing forward mode. The other reason is that even if you were properly operating the switch, if you moved that, the stabilization would jump to the Taileron stabilization whilst the wings are moving back. So for some time, there wouldn't be much stabilization. Similarly, switching forward, it would immediately jump to Ailerons doing the stabilization whilst the wings are, fully back at the start, and you wouldn't get the proper stabilization there. So what we'd like to do is have the mode smoothly move from the wing swept stabilization modes to the wings forward stabilization modes, but you can't, because inside the Jeti assist there's no such thing. It has to be in one of its stabilization modes or another. It can't do a transition between them. So we would like to set the assist mode switch to be basically run by the flight mode. So we can pick up the logic switch, which I think was logic switch 4, the A on B off switch, and use that to switch the stabilization mode. However, that would still give us the problem that it would jump immediately, because the A on B off switch was a pretty straightforward output, and all the delays were handled in the flight mode screen. Nevertheless, what we could do is modify things so that it will switch the assist mode when the wings are halfway. Yeah, so it gives us the best compromise. So let's look at how we can do that. Go back to the logical switches. There was L4. So what we're going to do is create a new one. What shall we call it? Call it gyro mode, because that's a bit quicker to type than assist mode. Okay, and the control is going to be logic switch 4, our A on B off switch. So prove that that's switching it. That's good, that's happy. Proportional. Yep. Okay. Now we'll come down. Do we need proportional? No, we'll leave it there as the switched one. No condition. But what we do want to do is not ramp, but hard switch at half the time it takes to sweep the wing. So the wing would be midway. we've said this is a 3.5 second time to sweep this wing, so we'll call it 1.8 seconds. Hard switch, 1.8 seconds. So now, when we sweep the wings, after 1.8 seconds, it'll switch on. And when we bring the wings forward, after 1.8 seconds, switched off. Good. So we can say OK to that. OK there. Come back to silly me, not basic properties, function assignment, and the assist mode is now that logic switch. That one. And so let's sweep the wing and see it. Good. Wing forward. Good. OK to that. Let's double check the servo output, which was assist mode 9. So channel 9, I'll move the switch, and after about 1.8 seconds it should switch. It does. 1.8 seconds, switch back. It's very important that it doesn't do a proportional travelling like the wing sweep as demonstrated there. And the reason being that, remember, the assist is looking for potentially a 3-position switch. And if you smoothly travelled along, when you get to near 0, it's going to go, that's the middle switch position, mode 2. And then the travel value keeps travelling and it goes then to mode 1 or mode 3. So you'd end up having to program something in mode 2 as well. It all gets too difficult. So we can say OK to that one. And next, fine tuning, free mixes. What we're going to do is mix from gain forward to the gain. And we'll come down here. It's going to be 100%. Now, rather than hard switch or switch when the wing's at the midpoint, it would be nice if on switching the wing forward, the gain on the ailerons smoothly ramped up. And we've already created a logic switch that does that. You remember, the very one that runs the aileron travel. So if we pick that, I think we want to take out the center, do we? Oh, it's done it for us. So it'll, with the wing swept, 0% mix. With the wing forward, 100% mix. Say OK. So the master value is 100. The wing forward, the actual output of the mixer is 100. Mixer's gone to 0 once the wing has swept. So let's have a little look if we've got any output yet. Now, as we can see at channel 10 then, the gain on the P8 knob does what we expect with the wing forward. Allows us the full range of travel. If we sweep the wing, it smoothly goes away to 0, which is not no gain in an assist. Remember, minus 100 is virtually no gain in the assist. But no matter, because we will now be overwriting the value in there with what we do on the P7 knob for the gain wing swept. So let's go back, go to our free mixes, plus now from gain swept to gain, master value, once again 100%, and the switch this time will be that Taileron switch that we made. And now we can see that if we switch it forward, and reverse it. It's the proportional we need, isn't it? So with the switch forward, we get 0 mix. Switch swept, we get 100% mix. Say OK to that. And now we can have a look at the channel. We've got wings forward, so it should work on the P8 knob. That's correct. And the P7 knob, as I rotate that, has no effect. If you're wondering what that is, I use P7 normally as the volume master volume control. Both knobs at -100. I shall switch to wing swept. So wing swept mode. Now P7 works the gain and P8 has no effect. So what would happen if we go midway? We'll put value on there from P7 in swept mode. I'll turn P8 down to sort of the opposite end. We'll switch. And there we go. So we've got smoothly varying gain. We've got a slight delay in the assist mode so that it waits till the wing's halfway, it swaps, and on we go. And remember, as it passes through 0, that in an assist, that's not 0 gain. That's about half the gain you've dialed up. Okay, so we're only using mad values to demonstrate it. I'll take the P7 swept value down to there. We've gone to the P8 value down there. So let's say that's the default. There's wings forward, and there's a smooth transition to the gain with wings swept. Okay, that's going nicely. Was there anything else we need to do? I think that's it, because we've set up our functions, we've set up the channels, and let's switch the assist on and do its settings. Okay, we can go into Model, into Device Explorer, into the X12 Assist. Now I've already done and checked its software update. I've done its 6 degrees of calibration. So let's go into Quick Wizard. It'll be an airplane. Yes. Next. Generic model. I shall choose Jet. You choose whatever you like. Apply changes. Next, default horizontal arrow pointing forward. It is. Yep. All servos digital. It might be on this model, I don't mind. Right, calibrate our ailerons. Pitch. And yaw, which we haven't actually got anything going for it at the moment. That's why I can't calibrate it. I didn't set any rudders up. It doesn't matter. The flight mode channel is going to be... now this is where I wish Jeti would allow this to be set manually, because it's going to look for the lowest channel number that moves, and that's not going to be our flight mode channel. Yeah, it's picked up channel 2, because that is the, I think that's the wing sweep channel. It just picks the lowest channel number that moves, and it won't let you do anything else with it. So we'll just have to accept that for a second. Apply wizard and finish. Yes. What we need to do is disable everything except the flight mode channel, which was channel 9. What have we got moving? Well, we don't need that one, because that one was the demonstration one just for the slow movement. I'll temporarily switch off the wing, and that should leave, hopefully, assist mode is the only one that's moving. Let's have a quick look in here. It was channel 9. So now if I do that, we can see the gain moving, but it wouldn't work, so it'd pick up channel 9. Good. Ah, the problems we run into. In configuration, channel assignment, assign additional channels, the flight mode channel, edit that. There, it's now picked it up. Flight mode channel 9. And if you remember, we set, what was it, 1.8 second delay on this. So if I flick the switch, it will go from assist mode 1 to assist mode 3 in 1.8 seconds. Good. And if I switch the wings forward, it should go to assist mode 1 in 1.8 seconds. Lovely. Come down to my assist off channel. Assist off. Okay, that's picked up the correct one there. And finally, the gain tuning channels. The roll tuning will be, if I move them, edit, move those knobs. There we go. So it's picked up the roll tuning. And of course you can, if you want, set the same tuning knobs for pitch as well. So we'll do that just so we get the value there, and we can prove it all. Good, that's that bit done. Now that those are all set, we can move on to disabling the ailerons when the wing is swept. So back into our settings. Down to the stabilization and flight modes. Now we saw earlier when we set the flight mode switch, which was coming from the assist mode switch, which is coming from wing forward and wing swept flight modes. It gets a bit confusing here because Jeti uses the same word mode, whether you're talking about assists or transmitter flight mode. So I will try and be very clear about it. We're in the assist flight modes, and we're switching between two of them, and it will switch between assist mode 1 and assist mode 3 because it's two position switch. We can see the active mode at the moment is 1, mode 1, assist is off at the moment, and if we sweep the wings we'll see it switch to active mode 3 after what, half of, what was it, 3.5 seconds, so about 1.8 seconds. There we go. So the wing swept is mode 3, and we'll use normal damping. That would be the normal one we use. However, when I'm setting up a gyro and testing it, I do like to use heading hold because it's much easier to check that everything's moving the correct way if the surfaces hold their position rather than just bump as the model's being moved. So you would set that to normal damping, that one to normal damping, and now when the wing switches between forward, which is assist mode 1, and wing swept, which is assist mode 3, this one, you'll get normal damping. But just for demonstration purposes, and as I say, what I do when I'm checking that I've got the gyro going the correct way every time, just use heading hold for that bit and then change it back to normal damping. And next we want to switch off the aileron servos in the swept wing mode, which was assist mode 3. So we go into there, we edit that, and For both of your modes, just make sure that damping only is switched on. It should default to that. Come down here. Notice the first column is roll. That's the one we're after, not pitch and yaw. We'll leave them alone because the aileron servos won't be responding to pitch and yaw anyway. And we can go down and see that the elevator servos will be getting gyro in roll and pitch, which is good. So we come up here to the ailerons and switch off the roll response just by pressing the programming dial. Come down, press the button, move around what you want, roll, switch it off, OK. So in mode 3, assist mode 3, which was the wing swept mode, the ailerons will not react, and it will switch off when the wing is about halfway back. And similarly, when you switch the wing forward, when the wing's about halfway forward, the gyro will start coming in again. And you can do much the same as this, certainly in the Bavarian Demon Cortex Pro. Can't remember if you can do it in a Cortex, because you would set everything up to switch between what they call bank 1 and bank 2, and you treat that a bit like your assist modes. You just access them in a different way. And so if you set up the system to, say, have bank 1 when the wings are forward, bank 2 when the wings are swept, you could switch off the roll bit in bank 2. I think you can do the same with an iGyro. I've never really investigated it that deeply. I do use iGyros, I should say. Very good gyros, as are Cortexes. I've just never had the need to investigate them that deeply. So that should do it. And what we'll say is, let's give it a try. Now, I'm in the wing swept forward at the moment, so the P8 knob should be working. I'll turn the P8 knob up very high. P7 knob, which was wings swept gain, I'll leave at the off position. And let's have a look. And assist, and I think all the other good gyro systems are good enough to recognize that when we did the calibration, the aileron only goes up. So if we rotate, there, you see how much easier it is with heading hold in place to check that things are working correctly. All I'm doing is manually rolling the receiver left, and that aileron's coming up. If I roll right, that servo's not responding in the same way as spoiler-on would. Let's check the tail planes. I will roll left. That's correct. Again, roll left. That one's going to up elevator. That one's going to down elevator. And now I shall sweep the wings. And we'll test here. Hardly anything should be happening because the P7 knob, which controls the gain when it's swept, is down at 0. And there we are, you see. So I'll turn up the P7 knob to about halfway, and we can test. Yes, you see, Tailerons are being stabilized, but not the ailerons. So I'll turn P7 down to a low gain value. Here we can see, and we'll sweep the wings forward, and we'll see the point at which the ailerons start stabilizing again, and we'll see a massive jump in gain because we've got P8 turned way up high. So if I can switch the wing forward and get to the gyro in time, we'll see the effect. There we are. So the ailerons are stabilized in the forward position, not stabilized backwards. We've got separate gains, and after you've landed, what you can do is simply look at servo monitor for the gain channel. Prove it. Servo monitor, which one was the gain channel? Gain 10. So channel 10, there is our wing swept forward gain, And if we sweep the wings back, there's our wing swept gain. So we could go to the function curve, change to constant, flight mode dependent, and set those gains in for each of our flight modes, not the assist modes, flight modes. And I think that's it. We've covered everything now. If I think of anything else after this, it's too late because I've done all my editing and published it. So I hope that's been a lot of useful hints and tips for programming an F-14 or any other swing wing. I keep my fingers crossed that one day Free Wing will come out with a Panavia Tornado. But that's it for now. Have a happy Christmas, folks. I'm recording this just before Christmas 2022. And we'll be back in 2023 with some more ideas I've got for helpful videos. Bye for now.